This is Edexcel's GCSE Mathematics Practice Test Set 2, Paper 3H. Question 1. Each year, Wenford Hospital records how long patients wait to be treated in the Accident and Emergency Department. In 2015, patients waited for 11% less time than in 2014. So in 2015, they waited 11% less than in 2014. In 2015, the average waiting time was 68 minutes. Work out the average waiting time for 2014. Well, we don't know what the average waiting time for 2014 was, but if we did, we would multiply that by 0.89, so 100% minus 11% is 89%. So to reduce by 11%, we'd multiply by 0.89 to get the time in 2015, which was 68 minutes. So to work out the 2014 time, we'd do 68 divided by 0.89, which is 76.4 minutes. Now it asks for the nearest minute, so that would be 76 minutes. The hospital has a target to reduce the average time patients wait to be treated in the Accident and Emergency Department to 60 minutes in 2016. Work out the percentage decrease from 68 to 60. Well, the decrease is 8 minutes compared to the original 68 minutes. And to convert to a percentage, we times by 100. So on your calculator, that would give you 11.76. So we'll round that to 11.8%. Question 2. There are only red pens and blue pens in a box. There are 12 red pens. The probability of taking a blue pen is 2/3. So 2/3 are blue. That means that 1/3 must be red. And we know that there are 12 red pens. So if 1/3 is red, then 2/3 must be double that, which is 24. So altogether, there must be 36 pens altogether. Question 3. Each length of the side of square B is twice the length of side of square A. John says that this means that the area must be twice the size. Is it correct? Well, if we think of a small example, a 1 by 1 square would have an area of 1 centimetre squared. If we double that to be 2 by 2, that would have an area of 4 centimetres squared. So that is actually 4 times bigger. So no, the area will be 2 squared, which is 4 times bigger. Question 4. Show that 7.5 take away 4 2/3 is 2 5/6. Well, to add and subtract mixed numbers, we need to first of all convert them to improper fractions. So 7 times 2 is 14, add your 1 is 15, so that'll be 15 over 2. 4 times 3 is 12, add your 2 is 16, so that'll be 16 over 3. A lot of students put this equal to 2 5/6, and that really gets confusing. We just want to work this out, first of all, and see that it gives us 2 5/6. So the next step is to get a common denominator. Now 2 and 3 both go into 6. So if we times that by 3, we get 45 over 6. Times that by 2, we get 32 over 6. If we take those away from each other, we get 17 over 6. And to convert that back to a mixed number, we do how many 6s in 17? There are 2 remainder 5, so that's 2 and 5/6, and that shows us that that's correct. Make t the subject of 5 brackets, t minus g equals 2t plus 7. Now, there are t's on both sides of this, so first of all we need to get them all together. And whenever we've got a set of brackets or a fraction in an equation, we want to get rid of those first. So the first thing I'm going to do is I'm going to expand those brackets to give us 5t minus 5g equals 2t plus 7. I've not done anything to the left just yet. I then want to get the t's on the same side, so I'm going to take 2 t's off both sides. So that'll give us 3t minus 5g equals just 7. So I've taken 2 t's off both sides. I now want to get the t's on their own, so I'm going to get rid of that minus 5g by adding 5g's. So I will get 3t equals 7 plus 5g. And just to get t total on its own, I want to divide by 3. So that's 7 plus 5g over 3 is our final answer. Question 6. Henry's thinking about having a water meter. There are 2 ways he can pay for the water he uses, either with a water meter or with no water meter. So no water meter is £107 a year, and a water meter is all these different charges. It says Henry uses an average of 180 litres of water per day. Now these are all talking about per year, so we need to convert that in a second. and Henry wants to pay as little as possible, so which one should he get? So, first of all, if we times 180 by 365, because there are 365 days in a year, that's 65,700 litres he uses each year. Now the costs up here are not in litres, they're actually in cubic metres, and it tells us that 1 cubic metre is 1,000 litres. So if we divide this by 1,000, that will give us 65.7 cubic metres. So it's going to use 65.7 cubic metres per year. Now the cost is 91.22 pence per cubic metre, so 65.7 times 91.22, that gives us 5,993.154, and that's pence, because this was in pence. Now everything else is in pounds, so if we divide that by 100 to get that into pounds, that's 59.93, and the 0.154 is not going to change that, so we're not going to round it up. And we want to add to that the standing charge of £28.20 per year. Again, we're using a calculator for all this, so that will give us £88.13 for the full year. Now you can't just leave it there, it actually asks you which one you should use. So you can't just think that that's obvious, you've got to state which one you should use, and obviously you should use a water meter. So Henry should get a water meter. Question 7. Cameron invests £1,200 for 3 years in a savings account. He gets 4.1% per annum, that means per year, simple interest. Now simple interest is different to compound interest. Simple interest means you just work out 4.1% and add it on each year. With compound interest, we work out the 4% in this case, and then we work out 4% of the new value for the second year, and 4% of that value for the third year. So, if we work out Cameron's first, 4.1% would be 0.041, just dividing 4.1 by 100, to put it as a decimal in a calculator, times the £1,200, and that will give us £49.20. Now, he's put it in there for 3 years, so on simple interest, you just do 3 lots of £49.20, which is, and then we also need to add to that the original £1,200 as well, which will give us a total of £1,347.60. So for simple interest at 4.1%, that's how much Cameron would get. Mitchell has a compound interest, but it's only 4%. So for Mitchell, we would do 1.04 because it's only 4%, and we would multiply that by the 1,200. But because it's the same interest rate for 3 years, we put that to the power of 3. So 1.04 times 1,200 to the power of 3, and that will give us, so 1.04 times 1.04 times 1.04 times the 1,200, and that will give us £1,349.84. Now, obviously there we can see that Mitchell's is better. So again, we've shown all our working, but we must state which one is best. So Mitchell will have the most. At the end of the 3 years. Question 8. Here are the first 4 terms in an arithmetic sequence. Now, a lot of people get confused with the word arithmetic. It just means it goes up by the same amount each time. Find in terms of n an expression for the nth term of this arithmetic sequence. Well, it's going up in sevens, so it must be linked to the 7 times tables. So the 7 times tables is 7 times any number, so 7 times n. Now the first number of the 7 times tables is 7, and our number is 3. So we need to take 4 off the 7 times tables. So the answer is just 7n minus 4. Is 150 a term in this sequence? Well, if it was, then 7n minus 4, whenever you put whatever the term is in as an n, it will give us the answer 150. So if we just solve this equation, add 4 to both sides, we get 154, and then divide by 7, we get 22. So yes, it is in this sequence, and it's the 22nd term. So we need to write that. So yes, it is the 22nd term in the sequence. Question 9. Here are the marks that James scored for 11 maths tests. Find the interquartile range. So you'll notice first of all these are not in order. So I'm going to put these in order. So the smallest number would be 11, then 12, then there are two 13s. The best way is just to cross these off as you go. A 16, two 17s, an 18, two 19s, and a 20. Just cross them off as you go. Now there are 11 math scores here. So will I be able to do 1, 2, 3, 4, 5? That would be in the middle. 1, 2, 3, 4, 5. So the median is 17. And the interquartile range is the difference between the middle of the lower end and the middle of the top end. So 1, 2, middle, 1, 2, 1, 2, middle, 1, 2. So the upper quartile is 19, the lower quartile is 13, 19 take away 13 is 6 for the interquartile range. Sunil did the same 11 maths tests. The median mark Sunil scored was 17 and the interquartile range is 8. Which one of Sunil or James has the most consistent marks? Well, consistency is talking about range. So if you've got a smaller range, you've got more consistency in your marks. So Sunil has an interquartile range of 8 and James is 6. So James is more consistent as he has a lower interquartile range. Again, you must write in full sentences, don't just put James. Sunil did 4 more maths tests. His scores for these 4 tests were 16, 20, 18, 10. How does his new median mark for the 15 tests compare with his median mark for the 17 of the 11 tests? So originally it was 17, but he scored a 16 and a 10, which are both smaller than 17, and an 18 and a 20, which are both bigger than 17. So that would mean that 17 would stay in the middle. So actually the new median is still going to be 17, it's going to stay the same. So to explain our answer, he's got 2 scores less than 17 and 2 scores more than 17. Keep 17 in the middle. Question 10. Expand and simplify p plus 9 brackets p minus 4. Don't get confused because there's p's here. Usually it's x's, but it's absolutely the same. So p times p is p squared. So we've done that bit. P times minus 4 is minus 4p's. 9 times p is 9p's. And then 9 times minus 4 is minus 36. And to simplify that together, we'd have p squared plus 5p's minus 36. Part B, solve 5w minus 8 over 3 equals 4w plus 2. Well, whenever we've got any brackets or fractions, we want to get rid of those first. So I'm going to multiply both sides by 3. I get 5w minus 8 equals 3 brackets 4w plus 2. I'm then going to get rid of those brackets. So I've got 5w minus 8 equals 12w plus 6. I then want to get all the w's on the same side. So I'm going to take 5 w's off both sides. I'm left with minus 8 equals 7w plus 6. I'm then going to take this 6 off both sides to get minus 14 is 7w's. And then obviously I want to divide by 7, and minus 14 divided by 7 is minus 2. Part C, factorise x squared minus 49. Well, there's no x's in the middle here, so it's going to be the special case where we end up with x plus 7, x minus 7. Question 11. The diagram shows Diana's suitcase. The suitcase is in the shape of a cuboid. Diana has a walking stick that folds, and the folded walking stick is a length of 60 centimetres. Diana wants to put the folded walking stick into the suitcase. Will it fit? Well, the greatest distance is going to be from corner to corner. So from that corner to that corner is going to be the greatest distance to fit this walking stick in. So we need to work out that distance. Now, that is the hypotenuse of a right angled triangle just there, with a height of 30, and this distance here we just don't know yet. But that also is part of a right angled triangle, which is 20 by 45. So if I call that x and I call that y, I want to work out x first, and I can use that to work out y. So I'm going to be using Pythagoras twice. So x squared is equal to 20 squared plus 45 squared. So x squared is equal to 2,425. Now, I can square root that if you want to work out x, and I get 49.244 going on. But in a second, I'm going to put that back into Pythagoras again. I'm going to be squaring it, so I might as well just leave that value there. So to work out y squared would be x squared, which we know is 2,425. I don't have to put all that back into my calculator now, plus 30 squared. So y will be the square root of 3,325, which is 57.66 centimetres. Now, obviously that's too short, so we need to write that. So we need to write no, it will not fit. Question 12. The surface area of Earth is that number there. The surface area of Jupiter is 6.21795 times 10 to the 10 kilometres squared. The surface area of Jupiter is greater than that of Earth. How many times greater? So we just need to put this into our calculator. We need to do the surface area of Jupiter divided by the surface area of Earth. And again, you can put that in just using standard form, or you could just put that in using a normal number, and you would get 121.903 ... Now it asks for your answer in standard form. So 121 would be 1.2, and I'm going to round that up to a 2 because of the 9. So 1.22 times 10 to the 2 times 10 to the 2. Question 13. Brian's band is playing at a concert in a hall. The loudness of the band varies inversely as the square of the distance. So inverse of the square of the distance to the band. Brian measures the normal loudness of his band to be 100 decibels at a distance of 5 metres. So, do they have to stop playing at 85 decibels over 5.4 metres? So, first things first, the loudness of the band is proportional to the inverse of the distance squared. So the loudness is going to be equal to the constant of proportionality over d squared. And we could put our values in. The loudness was 100 decibels, is equal to k over 5 squared. So 5 squared is 25. So to work out k, we do 25 times 100, which is 2,500 for k. So our formula is the loudness is equal to 2,500 divided by the distance squared. Now it says at a distance of 5.4 metres, the band has to stop playing if it's over 85 decibels. So if we work out the loudness at 5.4 metres, we do 2,500 divided by 5.4 squared, and that will give us a loudness is 85.7 decibels. So yes, they do have to stop playing. Again, writing in full sentences what you've found. Question 14. Q, R, S and T are points on a circle. A, T, B is a tangent to the circle. So this is A to T to B is a tangent. Angle STR is 26 as shown, and angle RQT is 73 as shown again. Work out the size of angle STA. So we're after this angle here. Now, we're going to be using circle theorems, and if we look at this angle here, that is actually the alternate segment theorem, shows that it's the same size as that. So this angle here is ATR. So angle ATR equals 73 degrees because of the alternate segment theorem. And then if that's 73 degrees, then to work out the angle that we're after, which is STA, so angle STA equals 73 minus 26, which equals 47 degrees. Question 15. The histogram shows information about the times in minutes that some passengers had to wait at an airport. Work out the percentage of passengers who had to wait for more than an hour. So an hour is 60 minutes. So we're after all of these people here compared to all of the people altogether. So we need to work out all of the people altogether, which is the area of each bar. So the first bar would be 20 times 12 and so on. So if I write that out in full, we'd have 20 times 12 for the first bar. For the second bar we'd have 10 times, and that is at 10.8. So 10 wide and 10.8. The next bar is 15 wide and is 7 tall. The next bar again is 15 wide and is 5 tall. And then the last two bars are 30 wide, and that one is 1.8 tall, and 30 wide by 0.6 tall. Now, if we add all those up, you can put it all into the calculator in one go, we end up with 600 as a total amount of passengers, and the last two bars, or just these last two here, are 72. So it's 72 out of 600, and to convert that to percentage, we just times by 100, which is 12%. Question 16. Given that 2 to the power of half to the power of n is equal to 2 to the power of x over 8 to the power of y, express n in terms of x and y. Well, this looks really difficult to start with, but it's really not. So it's just applying the laws of indices. So when you've got a power outside of brackets, these just multiply together to go together. So we'll have 2 to the power of n over 2, because a half times n is n over 2. And over here, we've got 2 to the power of x on top, and on the bottom, we can actually convert that to a power of 2, because 8 is 2 times 2 times 2, so 2 cubed. So this is actually 2 cubed to the power of y, so that would be 2 to the power of 3y, 2 cubed to the power of y. Now, if we've got divisions with the same base number there, we can just take the powers away from each other. So we'll end up with 2 to the power of n over 2 is equal to 2 to the power of x minus 3y. Now, I know you're not used to doing it with algebra, but it's still the same laws of indices. When we're dividing with the same base number, we just take the indices away. Then we can set up an equation. Now, we shouldn't write below this line, so we're just going to set it up over here. So n over 2 must be the same as x minus 3y. So forgetting the base numbers, that has got to be the same as that. So to get n on its own, I just need to multiply by 2. It'll be 2 brackets, x minus 3y. So we can get n is 2x minus 6y. So a little bit of a different application to the laws of indices, but it's just using the same laws of indices. Question 17. OAB is a triangle. OA is A, as labelled there, and OB is B, as we've got labelled there. Find A to B. So we're starting off at A, and we want to go to B. So we're going up in that direction. So to do that, we're going to go backwards along here, and then up here. So the backwards along an A would be minus A, and then up here would be plus a B. It says P is the point on AB, such that AP to PB is 3, 1. That means that if it's in the ratio 3 to 1, that's 4 parts. So this is 1 out of the 4 parts, and this is 3 out of the 4 parts. So it's 3/4 of the way along AB. It says find OP, so we're trying to get from O to P. So to get from O to P, we can go along here, and then up the vector we just found. So along here, so OP would be A plus 3/4 of minus A plus B, the vector that we just found. Now, if we expand that out, we'd have A plus minus 3/4 of A plus 3/4 of B. Now, adding a negative is the same as taking, so a full one, take away 3/4 of A, it just leaves you with 1/4 of A, and then 3/4 of B. Now, you can just leave it at that, but we should really factorise it out to be a quarter outside the brackets. So if we have a quarter outside the brackets, that would have A plus 3B. So 1/4 of A is that bit, and 1/4 of 3B's is 3/4 B's. Question 18. The sketch shows a curve with equation y equals ka to the power of x, where k and a are constants and a is greater than 0. The curve passes through the points 1, 7 and 3, 175. Calculate the value of k and the value of a. Well, when you've got coordinates, these are just the x values and y values to put into the equations. So we've got two sets of x values and y values. So if we put the easiest one in first, so x is 1 and y is 7, into our equation. So when y is 7, we've got k times a to the power 1. Now a to the power 1 is just a, So we can rearrange that to have that k is 7 over a. That will help us in a second. The second equation is that when y is 175, I'm going to just need a bit more space up here, x is 3. So we'd have k times a to the power of 3. Now we've just worked out that k is actually 7 over a. So the a would cancel with the a cubed and become an a squared. So we've got 175 is equal to 7a squared. Divide by 7, we've got that a squared is 25. So a must be the square root of 25, which is 5. So we've got a must be 5. Now if a is 5, we can put that into here. K is just 7 over a, so 7 over 5, and that's 1.4. So k would be 1.4. Be careful again not to draw to do any working out underneath that line, because that will get scanned into the marker's computer. Question 19. A and B are straight lines. Line A has equation 2y equals 3x plus 8, and line B goes through the points minus 1, 2 and 2, 8. Do lines A and B intersect? Well, basically what they're asking about them intersecting is, are they parallel? If they are parallel, they won't intersect, they won't cross, and if they are not parallel, then they will cross at some point. So we need to find the gradients of these lines to find out if they're parallel or not. So the gradient of a line is when we've got the form y equals mx plus c. So at the minute we've got two y's here, so we need to divide through by 2. So if we divide through by 2, we get y equals 1.5x plus 4. So the gradient of the first line is 1.5. For the gradient of b, to work out the gradient of a line, we do the difference in y divided by the difference in x. So the difference in y is from 8 to 2, which is 6, and the difference in x is from 2 to minus 1, which is 3. So 6 over 3 is a gradient of 2. So these lines are not parallel, so yes, they will cross as they have different gradients. Again, writing in full sentences what we found. Question 20. Work out the area of triangle ABC. Give your answer to 3 significant figures. Well, this question, when I marked it, a lot of students just went straight into a half AB sine C and just put these 3 values into that. Now, you've got to know that using half AB sine C for the area of a triangle, you've got to have the 2 sides and the angle between it. So we need that angle there. Now at the minute, we can't work that angle out straight away, but what we can use is a sine rule to work out that angle there. So, sine rule says that sine of the angle divided by its opposite side, so 36, is equal to sine of the other angle divided by its opposite side, which is 57. So if we rearrange that, we get sin x equals 36 times sin 48 over 57. And to work out x, we just do sin minus 1 of all of that. If you put that into your calculator, you should get 27.9 degrees. Now, I would leave that in your calculator so you don't lose any accuracy marks, alright? So leave that in your calculator, I'm going to use that in a second. So if that's 27.9, to work out this angle here, we're going to do 180 minus the 48 minus the 27.9, which will give us 104.1. Now that, again, should be more accurate. You should have all the decimal places in there if you've left it in your calculator. Then we can work out, you can use half AB sine C. So we've got the area equals a half times A, which is 57, times B, which is 36, times sin of the angle 104.1. Again, with all the decimal places in, just use the answer button to get the 104.1 in. And that will give us 995.49. And it asks for 3 significant figures, so because that's a 4, this will stay as 995 metres squared. Metres squared is already given to you. Question 21. The diagram shows a cylinder inside a cone on a horizontal base. The cone and the cylinder have the same vertical axis. That just means that they're in line with each other. The base of the cylinder lies on the base of the cone. The circumference of the top face of the cylinder touches the curved surface area. That just means that it's all lined up, so they've got the same centre. The height of the cone is 12 centimetres and the radius of the base is 4. Work out the curved surface area. Now we're given the curved surface area over here. It's just pi RL. So we've got R is 4. We just need to work out L, this distance here. Now the cylinder is actually no part of this bit. That's for the next part of the question. So we can just ignore the cylinder for now. So to work out the length of that side, we just use Pythagoras. So L squared would be 12 squared plus 4 squared. So L would be the square root of 12 squared plus 4 squared, which is 12.649. And again, leave all of that in your calculator display. So to work out the curved surface area, we do pi times r, which is 4, times L, which you've just worked out and you should have left in your calculator, or you can use your answer button, and that should give us 158.95 carrying on. But it asks for 3 significant figures again, so the first 3 digits are the 1, the 5 and the 8, the 9 means it's going to round up to 159 centimetres squared. Part B, the cylinder has radius r centimetres and volume of v. Show that v equals 12 pi r squared minus 3 pi r cubed. Now this isn't particularly obvious to start with, but we know that the volume of a cylinder is pi r squared times h. And we notice that there's no h in this. So the first thing we need to do is work out h in terms of r. Now if we look back at our picture, to work out h, the height of this cylinder, which is here, that is going to be in proportion. So this top cone here is going to be a similar shape to the full cone here. So we can use similar shapes. So going back to here, the height of the top piece of the cone is 12 minus the height of the cylinder. So looking back at the distance here, this distance here would be 12 minus the height of the cylinder. And that would be in the same ratio as 12 to 4, as 12 minus h is to r. So we can go back to here, and 12 minus h over r, so the ratio of the height of the top cone to the radius of that cone, is going to be equal to the ratio of the big cone, which is the height of 12, over the radius of that cone, which is 4. So if we start rearranging that, we can get rid of the fractions. So take the 4 up that side and the 12 up that side, sorry, the r up that side. So we'll have 4 brackets 12 minus h equals 12r. And if we expand the brackets, we'd have 48 minus 4h equals 12r. If we want the h's to be positive, because we want this in terms of h, I'm going to take the h on that side and take the r's on that side. So I'll have 48 minus 12r equals 4h. Just done a little double swap there. And then divide through by 4, I have 12 minus 3r equals h. So h is equal to 12 minus 3r using similar shapes. So we've used the fact that the top cone here is similar to the bottom cone, to the full cone here. Alright, so the height of the full one is 12 with a radius of 4, and the height of the top one would be 12 minus h with a radius of r. So that in the ratio to that will be the same as that in the ratio to that. So that's where the original came from, and we just rearrange that to get h. Once we know what h is in terms of r, we can put that into this equation. So we've got the volume is up to pi r squared times what we just worked out, 12 minus 3r. And if we expand that, we'd have 12 lots of pi r squared, take away 3 lots of pi r cubed, which is exactly what it asked for in the first place. So not an obvious question, using similar shapes there and the volume of a cylinder, but it's quite easy to follow through once you've realised that those two must be in the same ratio.